Hi, class. In this discussion, we're going to be focusing on local potentials. Local potentials can be thought of as an area of the cell membrane that has some electric potential charge, some change in the electric potential where ions move in and out. And there are different things that can stimulate local potentials. We can have light, heat, or mechanical disturbances, or a chemical stimulus. Multiple things can stimulate this process. So as we're looking at this, I want you to focus on the fact that we can have a chemical stimulus. This is one of the most common kinds of stimulants that generate local potential. And we can oftentimes have them occur at the dendrite. And if we have enough of a chemical stimulant, some kind of a ligand to the ligand-gated channel. When I think of a ligand, I want you to think of a chemical, just a generic chemical, or something that binds to it. Here we have a binding site that's being unused. Here is a ligand attached to the binding site. When that ligand attaches to the binding site, the ion channel goes from closed to open, and we'll have ions rush into the cell, sodium ions rushing into the cell. As we're going through this process, we have a sodium voltage or sodium ligand-gated channel. It opens, lets sodium in to the cell. Remember, we have a high concentration of sodium in the extracellular space and a low concentration of sodium in the intracellular space. And sodium will diffuse with its concentration gradient. Now, if we normally have a negative internal voltage, if we take positive charges from the outside of the cell, those positive sodium ions, and send the positive sodium ions into the cell, the inside of the cell is going to become less negative. And this is a depolarizing event that occurs. So as we have sodium rushing in, it's going to move the membrane potential towards 0 millivolts. And this could eventually cause a change in the cell's trigger zone, the part of the neuron right here, right over there at the beacon of the axon. And if we have a change in the voltage at the trigger zone, we can initiate an action potential if we have enough of a change. This very minor change that occurs is going to be referred to as a local potential. So when we think of a local potential, it's going to be a small change in voltage that fizzles out. If we have enough small changes in voltage, enough local potentials, make it to the trigger zone, so we have multiple local potentials, make it converge at the trigger zone will consolidate those local potentials and initiate the action potential. As those local potentials are moving, they are unlike action potentials in that they're graded. And that means that there's variations in magnitude. They can be more positives or more negatives. So they change in gradient. And when I say gradient, another way of thinking of this is they have variations in how much they manage or move the cell membrane voltage. We could have a big change in voltage or a small change in voltage. We also note that they are decremental, which is another way of saying that if we have our stimulus right here, here's our local potential, it can be pretty strong right here. But as we move farther and farther away, it becomes weaker and weaker and weaker. So the farther away we go from physically from the point the stimulus was applied, the weaker the local potential becomes. That's what we mean by decremental. Local potentials are also going to be reversible, which is the nice way of saying that is if we stop stimulating the cell, we're going to stop having that change in voltage. The cell will go back to its resting membrane potential. We also need to emphasize that local potentials can be excitatory or inhibitory. Some neurotransmitters are going to make the membrane potential more negative or hyperpolarize our membrane. So instead of making it more likely to initiate an action potential, these inhibitory neurotransmitters or these inhibitory local potentials are going to make it less likely that we produce the action potential and actually send a signal through this neuron, whatever neuron we're looking at the time. And that's all we have for this recording. As always, if you have any questions, please feel free to post them on the class discussion board or to shoot me an email, and happy studies.